here is the dry assembly, and I say it's a dry assembly. There's actually no glue holding this together at all, apart from a little bit of sellotape, of the weather station. Now what I wanted to do is actually break this down step by step so that you can actually see where everything goes, you can understand what the pieces do, purely by having seen this thing come apart. Now then, we'll start by taking out the anemometer. That is intended to be as close as it possibly can to this red vac forming, with a view that what that does is try its best to keep the rain off, and hopefully it'll be windy and rainy, and that middle disc will stop the rain running down the middle of the axle. If it does the odd drop, then we have got ways to cope with it further down. The blue section, blue former, is again intended to try and shed the rain away so that it doesn't ingress into the system. That has no holes in it whatsoever. That is purely straight off the vac forming. Again, the yellow louvres are intended to try and shed rain away, but on the underside of the louvres, that should have at least 5 holes about 3mm all the way along each one of the louvres to allow the air to pass through, so the humidity sensors, temperature sensors are getting an accurate view of what's going on outside the actual unit. I haven't fitted the solar panel, partly because of this has been a dry fit. It is quite heavy, it could pull off and actually damage the panel. We've got the rain collector unit there with a little dish on the top, and what I will do now is I'll literally take each one of these apart so that you can understand the actual assembly by effectively doing it in reverse. We'll take off the anemometer. That not only just sits inside, there is a disc on the underside there which will allow it to, which runs around the actual sensor, so normally that would come with it, and I would actually be sat partially up the top there. As soon as you put the disc on the bottom with the magnets in, the magnets then trip the sensor on the top there to come, so that it can actually detect it spinning round. These, on this side, the louvre doesn't protect anything, but on this side, if I can gently turn this round, you'll notice on the inside is the rubber duck for the aerial, to actually do the transmission circuitry if you're using that. You can just quite as easily put a piece of wire will do. The rubber duck does give you a little bit of gain on your signal. A wire 6.47 inches long is the length that the signal frequency that we're using needs. So you can just as easily tape that or glue that on the inside of there and have a wire going down to your circuit board inside. I'll turn this a bit further round. And this again, this whole top section is machined separately and would normally be glued on there. We'll take this one apart just so you can see what's inside it. There's effectively 4 levels in there, purely for strength. The top 2 hold the rod for the anemometer, and the bottom one is purely there to stop the rod dropping through, so that you don't have to have a very long rod. Plus, if you want, you could also put a metal plate on there so that it reduces the friction. So that's your anemometer tower. We'll move round to the actual rain section now. Now the rain section has the disc on the top, dish on the top. What that does is basically does the collection. Now then, you want right. So what I've done is I've actually drilled a 3mm hole in the middle. You don't want it much bigger because you don't want any insects getting in. And then you put a little wire facing down, and what that does is that it makes sure that there's no surface tension builds up, and it also guarantees that drips always fall in the same place. There's a hole in the top then for the rain to drop through, and if we actually lift off, okay, I'll take the base or the top off. If we take the base off, you'll notice that there are holes in the base for the rain to get back out, and on the top side there actually are little sunk sections to make sure that the rain isn't slopping around inside as the seesaw runs. Then inside we have, if I take the top away, it'll let me. I'll say it's a dry fit, but because of the way that this works, it is a very good fit. It's not going to let me. What you've got inside there is a little seesaw. You're looking at it from the underside now. So what happens if I take the pinion out, that seesaw sits where, as the rain builds up, and as the rain builds up it tips over, so that the other side then collects it. As it's tipped over, it automatically empties itself and then tips back. So that, and in the top corner there is a little magnet, which there's a hole on the side there to put a little trimetric Hall effect sensor in, and the hole then, the wire would then go back down the arm and into your control system. Right, so what we're going to do now is actually take off the side panel. This allows us access to the electronics, so that at any stage that if we want to go back in, take the electronics out, do any changes, reprogramming the chips, we can do that literally by taking that side off. As it's dry fit, nothing's actually put in there properly, it's more so you can see how this unit comes apart. The section for the solar panel comes off the side, and then the next step we would want to do now is literally take out the processor board, just so as you get an idea how the last part section goes. The main body is just sat, so that at any stage if you wanted to take that away, do some maintenance on it, you can do. You don't have to constantly work in the field, and that is just a post for the unit to stand on. So that gives you an idea roughly how it comes apart. Of course the front and back come apart, the walls come apart, there's not a lot to that, but you can actually get a feeling now of the way the whole unit comes together.